Okay, so there is a problem from my side. There is no electricity due to heavy rain. So I don't think the camera is not really catching my image because there is no light, right? So let me just see. Yeah, it's not in focus. So I might have to close the camera. Okay. So what we will do is, so 1, 2, 3, 4. Yeah. So I will take presentation for 4 people and other people. You might have to join Mr. Saurabh Singh and Akash Ramba's session. Okay. I believe you should have the meeting link in the email itself. So if we get disconnected or there is some technical issue, just join their meeting and give your presentation to them. Okay. But if you are not able to give the presentation, then what you can do is you can join tomorrow and give your presentation to me. If needed, we might extend tomorrow's session. Okay. So we'll start with the Hemang Raj.
Hello, good evening, sir. Is my camera visible?
Yes, it is visible. Please share the screen.
Yes, sir. I'll be sharing my screen. Uh, Sir, is the PPT visible?
Yeah, you can start.
Okay. So, good evening, everyone. My name is Hemang, and I am from machine learning and deep learning domain. My task was to do predictive modeling. So, this is the table of content which I'll be going through my presentation. So, let us start with the first question. What is predictive modeling? According to the definition, predictive modeling is the process of using historical data to make predictions about future outcomes or events. I'll make it simpler for you. When we were in 10th standard, all of us gave trial exams or preparatory exams or pre-boards exams, the exams which we had to give before our board exams to prepare ourselves. There used to be 2 or 3 of them. So if you analyze carefully, if you take the average percentage of all the 3 preparatory exams you have given, it and the actual marks which you have got in board exams, the difference will not be more than plus or minus 5% between your actual board examinations and preparatory examinations. So this was the basic sort of prediction which we used to do according to our preparatory marks. The real life example of this we can see in Kota. There is a coaching institute which is called Motion, which has installed a device which sees students' past performances and predicts the final score or the mock test score which the student scores in JEE mains. This is the real life application of predictive modeling. So what actually happens in modeling is first we collect the data, then we build a model upon that, and then we predict the actual values. In my case, my data, I will show you the data. This is the data which I have. We have math score, reading score, and writing score along with other data. What we have to do is using other data, we have to predict the math score of students. So let us do that. First, we have to load the data into Jupyter Notebook. After loading the data, we do some basic visualizations. So we have a total of 1,000 rows and 8 columns in our data, and we don't have any null values. The columns are gender, race, ethnicity, parental level of education, lunch, test preparation course, math score, reading score, and writing score. Next, we have to understand the data. This includes the data types, value counts of each feature, and mathematical feature. I'll go through everything one by one. Data type, as we all know, it is integer or object data type. Mathematical values is count, mean, standard deviation, minimum value, interquartile ranges, and all. Next, we do some basic visualizations to understand the data better. The first chart is gender versus math score. We can see male and female. The male comparatively performs better in our data in math test. Then we have math score versus race and ethnicity. Group E is the best performer among all the groups. And then we see parental level of education versus the math score. In the next 2 chart, we have test preparation course and math score. Here we can see students who have completed their test perform better than students who have not taken any test. And similarly, we do that for the lunch. In all these 5 charts, one thing which is common is the math score always remains on y-axis and all other values are on the x-axis. This says that we have to predict math score only. That is why we are taking math score into account into all the charts. Next, we have 2D and 3D chart. The first one is reading score versus writing score. When we plot the chart of reading score versus writing score, we see the chart is linearly increasing. This means that if a student has more reading score, indirectly he has more writing score. And as the reading score of a student increases, writing score also increases. So reading score and writing score are directly proportional to each other. In the next chart, which is on the right side, we can see when we plot a 3D chart of math score versus reading score and writing score and reading score were already linearly proportional to each other. Math score is also directly proportional to both of them. That means all the three are in a linearly increasing fashion of each other. I will show you all these three in my code. This is my code. I have loaded the data. After loading the data, we have to check if the data is loaded properly using head and tail. After using head and tail, this is the type definition of data. What type of data we have? It is object or integer type. Then we describe the data, math score, reading score, writing score, all the mathematical features of that. Shape of the data, as I already said, is 1000 into 8. We check for null values. We can see there are 0 null values. That means our data is already clean. One more feature which I have used is value count. Value count gives us how many different types of values are there. Like there are two genders, male and female. Out of 1000, we have 518 female and 482 male. Similarly, for race, we have 5 groups. Each group, how many number are there in each groups are defined. Same thing for parental level of education, high school, some high school, bachelor's degree, all the numbers are given. Similarly, for lunch also it's given. For math score, the numbers are very vague because it can go from 1 to 1000. So it is not, all the numbers are not displayed here. Then for test preparation course, we have 2 types: students who have not taken any test or students who have completed the test. Similarly, for reading and writing score. These are again the mathematical features for reading score, writing score, and maths. These are the box plot summary, which I showed you in my presentation. I'll be moving on with this. Next, what we have to do is we have to build a model to predict the math score based on the values which we have. We have many values. We have many columns: reading score, writing score, parental level of education, lunch. So we have to first decide on which feature or which target we have to build a model. For that, we do a chi-square test. And in that chi-square test, see, this is the code for chi-square test. In this chi-square test, we get the grouped column score. The first one is writing score, second one is reading score. That means writing score and reading score are the most effective features which we can use to predict the math score of the students. We got this we do using chi-square test. We get this. Now we have to perform linear regression. So what linear regression is? Linear regression is the dependency between independent and dependent variable. We have to build a model on linear regression. And we must perform feature selection using the chi-square test. We selected the features. Those are reading score and writing score. Then we build a model. After building the model, how should we come to know? How do we come to know that the model built is correct or the model built is perfect? For that, we use 2 things. One is RSME, which is root mean squared error. And the second one is R2 score. RSME gives us the difference between actual value and predicted value. And R2 square is also a matrix which we use to find the accuracy of the predicted data. Additionally, we use cross-validation to estimate the model's generalization performance. So we see that the best RMSE score we get is around 2.89, and R2 score we get it as 1. R2 square varies from 0 to 1. So if a model is giving us R2 square of 1, it means that it is giving us the perfect numbers. That means actual and predicted values are the same. We tried with several other algorithms. The other algorithms are decision tree regressor, logistic regression, and random forest regression. Here we can see that R2 square is 0.99, 0.65, and 0.99. Decision tree regressor is also gives us the relation between independent and independent variable, but it does not gives us the linear relationship. In linear regression, we have the direct relationship like a straight line, but here it doesn't take into account the straight line relationship between dependent and independent variable. Logistic regression is a classification algorithm. Random forest regression combines several decision tree algorithms or decision tree models to predict the score. Next, we have to find the best model. To find the best model, what I have done is I have calculated the R2 score for various other models. See, this was the R2 score for a linear regression. We get it as 1. Next, we calculate the R2 square and RMSE for descendant regressive logistic regression and random forest regression. Next, for many other algorithms like ADA boost, XGBoost, gradient boosting, decision tree regressor, linear regressor, lasso layers, and SVR support vector, we calculate the R2 score. Looking at these R2 scores, we still find that the best algorithm is linear regression itself. That means the direct relationship between dependent and independent variable. So we go ahead with building the R model with the linear regression using reading score and writing score. Why we use reading score and writing score is because that was the best target variable which we got using chi-square test. When we build that, we see that using linear regression, there is no difference between the predicted value and the tested value. That means the actual values. We see that 91, 91, 53, 53, we get the same values. Why? Because R2 square was 1. So these are the predicted values which are same as actual values. Now what we do is we try to plot a graph between actual values and predicted values. If our actual values and predicted values differ, that means if they are different, that then we can say then we can see the difference in any bar chart or any graph. But if our actual values and predicted values are same, the graphs will superimpose each other. That means we won't be able to see any difference. I'll show you. I have used two colors to the blue color is for test actual values and the orange color is for ensemble prediction. We don't see any of the blue color. Why? Why is it like that? Because there are no difference between the actual value and the predicted value. So the graph superimposes each other. This was about the prediction. From this presentation, we can conclude that from for our data set, linear regression gave us the best R2 score among all other algorithms. Some algorithms were almost 0.99, which is equal to 1, but linear regression actually gave us 1. If we get an R2 score of 1 for any data set, that means we won't have any difference between actual values and predicted values. Actually, it is very difficult to get 1 as R2 score in real life scenarios, but in our case, we got it as 1. Then for our data, reading score and writing score are the best features to build the models. Why is it like that? Because math score is again a marks and reading score, writing score are also marks. So marks, from seeing the marks of few subjects, we can judge the child's performance in other subjects also. So similarly, reading score and writing score indirectly drive the performance of mathematics score of any student. So this was my presentation. If you have any questions.
Yeah, Hemang, just give me 1 second.
Yes.
Yeah, sorry about that. See, your presentation was good. Okay. You start, I think it was quite rushed today. See, when you're starting, as I have said also previously, so when you start, right? So if you just directly start with your story, so people are not able to keep up with it. So that is why I say always start by giving the introduction on what your task is, like how your task is working, and then you can start with your story so that people will have some time to follow up with your story. Second is that I think during today's project demonstration you rushed the models part quite too much, because the models part I think was not really well explained during the project. But it was explained in the presentation, but still I think it can be improved. So try to work on that. Only thing in today's presentation was that you rushed the project demonstration part. Okay. So try to work on that. Other than that, it was okay. So we'll I think move on to next intern. If you don't have any other presentation.
No, thank you, sir.
Yeah, thank you. So Palak.
Hello, sir. Am I audible?
Yes, you are audible.
Sir, am I visible?
Yes, you are visible.
Sir, is my screen visible?
Yeah, you can start.
Good evening, everybody. I'm Palak Tandon, and I'm from Java Programming Group. And today's task is software development lifecycle for stock trading application. So these are the table of content. First, we'll see introduction, stages of software development lifecycle, then types of software development lifecycle model, then SDLC model for stock trading application. Finally, we'll see benefits, conclusion, and then references. So introduction. So like in this current digital era, everything is changing and software developers are trying to make a software application in order to solve the real world problems. So for doing so, they are making various applications, and for making applications, they are using SDLC. So what is SDLC? SDLC is basically a framework or a stepwise guideline for making softwares. And those softwares are high quality, and they are made cost effective and time efficient. SDLC defines the complete cycle of development. That is all the tasks. Like the whole process is broken down into tasks of planning, then designing, then making, building, and then deploying, and finally testing, and then deploying the whole application. Stages of the software development lifecycle. First, planning. Planning is done to ensure the smooth going of the whole process. Planning is done for the cost estimation, time estimation of the project, and also about the requirements. Requirements are those things which are required for making the whole project. Design part. Design is when a web developer or front end developer comes in and who creates a design like visual appeal to the software application to be made. Then coding part. Coding is also called development or implementation stage. At this stage, the design part has come into action, and code is written from in a specific language, and then we build what we want. Then comes testing. Testing is done to remove all the bugs so that users can have a good experience. The purpose of this stage to emphasize the use of automated tests to prevent defects in the software, that, as I said, to improve user experience. Then release and deployment. After all the bugs are removed, finally, users are given access to the application, and hence the application is deployed. Monitoring stage. Monitoring stage is also known as maintenance stage. Here, when users use the existing application, they give their feedback, and those feedbacks are incorporated, and again, the existing software is altered according to users' requirement. And it is also noticed that it is also ensured for optimum performance of the developed software. Types of SDLC models. First, waterfall model. Waterfall model is the oldest and the most simple structured SDLC. It arranges all the phases sequentially in a form of waterfall, and hence it got its name. Each phase begins only when the previous phase has been completed, and each phase depends on the outcome of the previous phase. It is not a very flexible model, and it is only suitable for short-term projects, and it is not most widely used. Agile model. It is one of the most flexible model and most widely used nowadays. It arranges the SDLC phases into several cycles, and after each cycle, we see the gradual improvement of the whole product. The team iterates through phases rapidly, delivering only small incremental software changes in each cycle. It is very effective that it contains both iterative and incremental models. Continuously evaluation takes place. Alterations can be made after users' interactions, and hence their thorough planning is not required for this model. Changes can be incorporated after each iteration. Iterative model. Iterative model, as the name suggests, it requires iteration or loops. We implement the requirements, and then we test those, and then further we can pinpoint the further requirements. Like, we don't need to know the whole requirement for beforehand. Requirements can change from time to time. A new version of software is developed after each iteration, so we can get a working model in a very early time. Spiral model. It combines the iterative model and waterfall model and prioritizes the risk analysis. It is also known as risk-driven model. It lays huge emphasis on evaluation of risks. The whole project passes through phases of plan, build, and test again and again over a spiral form. It builds a highly customized product, as it involves a high collaboration between developing team and users. But sometimes the only the disadvantage that sometimes the spiral may go unending. It was also one of the most flexible and nowadays used model. V-shaped model. V-shaped stands for verification and validation. It lays great emphasis on testing. Great experts of or testers are required for this model. It grew out from waterfall model. Same thing happens here. First, a stage needs to be completed so that other states begin. It is useful when all the requirements are known from beforehand. Hence, it is not a flexible model and it is not used often. Incremental model. The model is divided into small sections or stages. So all the functionality is added in each state. It requires good planning. We should know the whole complete and fully functional system from beforehand. And planning should be done thoroughly for this. RAD model. RAD stands for Rapid Application Development. It is a type of incremental process with extremely short development cycle. Extremely short development cycles can range from 60 days to 90 days. One of the most striking feature of RAD model is use of powerful development tools and techniques. It also one of the advantage of this model is that features reusability is allowed. High technical risks are there, so good experts are used in this model. Prototype model, as the name suggests, prototype means a blueprint or a blueprint of the original or a small sample of the original product to be made. So here a blueprint is made and then users give their corrective feedback. Again, the product is refined and then users again give the corrective feedbacks. So this results in high satisfaction of the users as again and again their feedback is incorporated and hence it got its name prototype model. It is only used for short demonstration purpose, not from long-term process. So SDLC model used for stock trading application is Agile. And the reason why I have used Agile is because of its flexibility and adaptability. It is very flexible. We don't need to know the whole requirement from beforehand. Like requirement can be changed and model can be altered according to user. Stakeholders collaboration is there. Like there is a good collaboration between the developing team and traders, stakeholders, and the feedbacks are incorporated into the application. Fast time to market. This is a good advantage for dynamic stock trading application. Continuous testing and quality assurance is a good feature for removing all the bugs so that users get a good experience. Risk mitigations. The risks are already handled in an early on in an agile model. So risk mitigation is one advantage. Transparency and visibility. Transparency ensures trust and visibility that users are able to give their feedback. They have access to the model. So these are the reasons why I have used agile model. Then benefits. Benefits is it has a structured approach. It is in a systematic, well-formatted documentation. It helps to estimate the cost and time. Project activities and deliverables of each. It includes project activities and deliverables of each phase. It boosts transparency of the entire project and development process. Verification. All the bugs are removed. Risk management. Evaluation of risk is done. Collaboration. There is a good collaboration between the user and the developing team. Conclusion. So software development lifecycle is a process or a framework which is used by developers to build a high quality of software using specific guidelines or steps. So a suitable SDLC model can be selected based on customers' requirement and the objective of the organization. We can use SDLC models such as waterfall, agile, incremental, iterative, spiral as per the use. The benefits can be only realized if the developers has understood the customer's requirement and strictly follows the documentation laid in the SDLC. These are the references which I've used for making presentation. Thank you. And if any questions are there, please ask.
Okay, yeah. So am I visible now? Hello? Hello, Palak. Can you confirm if I am visible?
Yes, sir, you are visible.
Yeah, yeah. Okay. See, it was a good presentation, but you need to work on your overall presentation skills, right? Because it looked like you were mostly reading from the slides, and that is not how it should be. Second is that you did like there is a good research on various models of software development, but when you are doing a presentation, you are supposed to also cover part like how we can apply those model on stock trading application, right? So I think that was quite missing and not well prepared. So next time I want you to focus on that part also. Second is that it is okay for the conclusion, but I think that can also be improved. Okay, so overall just work on that part. Second is that your PPT can also be improved. See, you have good content, but I think they are not well formatted as well as not well put together. So work on that part. Other than that, I would say it is okay. Content is also good enough for now. Okay.
Thank you, sir.
Yeah. Okay. Thank you, Palak. So we'll move on to Shivanshu Saini.
So my video is visible.
Yes. Yes.
I am sharing.
How many presentations are you doing?
Is my screen visible now?
Yes.
So, good evening, sir. My presentation topic is prescriptive analysis. The task given to me is prescriptive analysis. In this task, I have to focus on prescriptive analytics, the most advanced stage of data analytics. The goal is to optimize a specific process or a system by recommending the best course of action. To achieve this, I have utilized powerful optimization algorithms, including linear programming, integer programming, and mixed integer programming. So in this task, what I have done is, firstly, I have done the expert data analysis of the data provided to me. Then I have used various models such as XGBoost, Arima, and Sarima. And out of these, Arima and Sarima perform well. XGBoost does not perform well. So we will see how these models work. So first of all, what is prescriptive analysis? Prescriptive analytics is the advanced stage of data analysis that leverages mathematical algorithms and optimization techniques to recommend the best course of action to achieve objectives. Prescriptive analytics offers several advantages such as data-driven decision-making, improved performance, and the ability to balance various constraints and objectives. And by leveraging these techniques, one can identify the most efficient and effective solutions for the given process or system, leading to better business outcomes. So first of all, we will look at the data. The data set consists of 10 lakh rows and 6 columns to represent a specific product demand entry, and the column contains information such as date of demand, product code, warehouse, product category, and order demand. We will explore this data set to understand its data its structure and characteristics. Firstly, we will do exploit data analysis to do deep dive into the data set and do data cleaning. Before diving into data analysis, we need to handle missing data. The data set contains 0.73% of missing values, which correspond to around 7,300 rows. To ensure data integrity, we will drop these rows from dataset. Then we will perform univariate analysis. So firstly, what is univariate analysis? The univariate analysis means analysis done on the one variable. And in our analysis, by looking at the demand of each warehouse individually, warehouse J has the highest demand, followed by warehouse A, S, and C. So then we will perform category analysis, and we will see this category 19 has highest demand and contribution, then category 6, then category 5, and category 7. Then we will do time series analysis. Then what is time series analysis? Time series analysis is a specific way of analyzing a sequence of data points collected over an interval of time. In time series analysis records data points at consistent interval over a set of period of time, rather than just recording over data points intimately or randomly. Now we can see that our data set is a time series data. It means the data points are collected over a time freeze of data or time. So we can see here from 2011 to 2017 we have the data. So we will plot the demand trend over time. This line chart will visualize the variations in product demand over the entire historical period. This analysis can reveal any apparent patterns or trends in data. So we will next go over multivariate analysis. Next, we will perform multivariate analysis to understand the demand distribution across different warehouses. The bar chart will show the total demand for each warehouse, allowing us to identify warehouses with highest demand. Warehouse J has the highest demand, and then warehouse S, then warehouse C, then warehouse A. In addition to total demand, we will explore the average demand for each warehouse. The bar chart will highlight the warehouses with highest average demand, providing insights into the most consistently demanded project. Then when we will do train test split, because we in machine learning we have to do the train test split, because we have to give train set to our modeler so that he can train then test set for prediction. So I have split the data set such that from 2012 to 2016 is my train set. Then after that is the test set. Then I have used XGBoost model, our first predictive model, and will be built using XGBoost algorithm, a popular gradient boosting technique. Firstly, I will train the model on training set and evaluate its performance on the test set. The model will identify the importance of each feature in forecasting demand. Using the trained XGBoost model, I will make predictions for the test set and compare with the actual demand. This will allow us to access how well the model captures demand in this data set. So here is our real demand, and XGBoost predicted is shown by yellow dot. So it is not visible in this graph properly. So you can see that here yellow dots are here, the bottom line. It shows that XGBoost does not perform very well. Then we'll do train time series analysis. Continuing our time series analysis, we will use box plot to visualize the demand distribution across different weeks. This will help us to identify any weekly patterns in the product demand and understand if certain weeks consistently experience higher or lower demand. Then, to gain deeper insights into demand patterns, we will resample data on weekly basis and plot average demand for each week. This will allow us to observe the demand trend over time and identify any seasonal patterns at a weekly frequency. And it is our monthly demand. Then we will see time series decomposition. To decompose time series into its constant components such as trend, seasonality, and residuals, we will use seasonal decomposition technique. This will help us better understand the underlying patterns in the data. Then we will use ARIMA model. ARIMA model is used as forecasting tool to predict how something will act in future on past performance. It is used as technical analysis to predict our future asset. But before building the time series model, we need to ensure that data is stationary. To test stationary, we will use augmented Dicker-Fuller test. The p-value obtained from the test will indicate whether data is stationary or not. Based on the data filler test, if the date is non-stationary, we will take first difference to remove the trend. Then we will build ARIMA auto-integrated moving average model to forecast the demand. We'll use ACF and PACF plot to determine the ARIMA method. These are the autocorrelation and partial autocorrelation plots which are used for building the ARIMA model. Then after fitting ARIMA model to different demand data, we will make predictions for test set. The model performance will be validated using root mean square, which measures the accuracy of the model prediction. So first, here's the test set. Then it is from orange line, we can see the fitted values. Now SARIMA model. SARIMA stands for Seasonal Autoregressive Integrated Moving Average. It is extension of ARIMA that can account for seasonal patterns in the data. To account for seasonality in the time series, we will build a seasonal autoregressive integrated moving average SARIMA model. This model will capture both seasonal and non-seasonal pattern in data. We will use ACF and PACF plot again to determine SARIMA parameters. So here we can see it is the test set or test set and it is fitted values. Now we will taking results of original scale. We will convert our prediction to original scale, reversing the differentiating operation. Now it is a demand forecast. We will use our SARIMA model to demand forecast for 2017 year. So here it is the product demand, and from orange color I have shown the future demand. So by SARIMA model I can predict how is the future demand after 2017. So it is shown is like this. In conclusion, our EDA and time series analysis have provided valuable insights into product demand patterns. In predictive analysis models, ARIMA and SARIMA have enabled us to forecast future demand accurately. These insights can leverage for better decision making and inventory management, ultimately improving operational efficiency and customer satisfaction. So we can conclude from here that the increase and decrease in demand is based monthly on seasonal demand and occasions, and seasonality is measured by a SARIMA model. Here the acknowledgement I would like to express my gratitude to my data provider Kaggle and the YouTube channel where I have learned this predictive analysis. And any questions? Thank you.
Okay, so your presentation is done.
Yes.
Okay. See, I would say it was a good presentation. Okay, you have tried to include everything, but work on your presentation skills, because your presentation was good, but it looked more like like you are reading an answer of a question. Okay, it looked like that. So work on your
Okay.
book. Okay, because see, just giving presentation is not the goal. Okay, because you have done the task and then you are just letting me know how you have done the task. That is not the goal. So imagine that if there is a client, okay, and you have done this prescriptive analysis on a client data. If you give presentation like that, you will not get anything. Okay, so I would say that try to simplify your presentation, try to give more examples that will be like make sense. Second is that I would say work on your hook. Okay, if you have a good story or let us say good examples, they will help you create a hook. Second is that I think your conclusion can be improved. Try to include some numbers that you have got from the task. That will be better. Okay, because that is
Okay,
what a result of conclusion, right? So try to also include some numbers. Okay.
Thank you, sir.
Yeah, thank you, Shivanshu. So I believe we can move on to Prithvi Poojari.
Yes, sir. Am I audible?
Yes, you are audible. Please turn your camera on, share the screen.
Just a minute, sir. I'll use two devices to share information. Is my screen visible?
Yeah, please turn your camera.
Okay.
Yeah.
My camera is working, sir?
Yes.
Okay, sir. Just give me a minute. One second, sir. So the presentation is visible, right?
Yeah, your camera is not visible.
Just a minute. Am I visible now?
Yeah, that's right.
Okay. So good evening, everyone. My name is Prithvi Poojari, and I will be giving a presentation on the topic on the task predictive modeling. The project name is Understanding Descriptive, Diagnostic, Predictive, and Prescriptive Models. So these are the contents of the presentation. So the first objective is to build a predictive model that can sort of predict the math scores of a student based on various sort of different variables. Then we were told to use supervised learning algorithms. Then we have to evaluate the model using appropriate metrics. In this case, we have used the R2 score and the RSME score. Then we have to use feature selection techniques to identify the most important features for predicting the math score. So let's try to understand what exactly predictive modeling does when it comes to, specifically predicting, student performance, and how exactly we can use those predictive analysis to improve our strategies to get better scores. So let's say like predictive modeling sort of plays this crucial role in enhancing student performance by providing valuable insights into student behavior, learning patterns, and academic outcomes, and by leveraging all of this historical data and advanced analytical techniques. So just a minute. The presentation is visible, right?
Yeah.
Yeah, okay. So these models analyze various factors such as previous academic performance, attendance, engagement in class, and other relevant data to create these personalized profiles for each student. I'll be talking about the different variables that we have used for the prediction. Now, in addition to supporting students facing academic challenges, predictive modeling has also been found to benefit high achieving students by offering all of these enrichment opportunities and personalized learning pathways. And by analyzing their strengths and weaknesses, and educators can then tailor advanced coursework and extracurricular activities so that in order to cater to individual talents and interests. Now, this personalized approach not only keeps high performing students engaged and motivated, but it also helps them to reach their full potential. Now, let's try to understand the need for predictive modeling as a whole when it comes to understanding student performances and in predicting scores. So the first one is early intervention. Now, predictive models can identify at-risk students early in their academic journey, and by analyzing historical data and factors such as attendance, grades, and engagement, educators can then intervene promptly and immediately to provide additional support and resources to struggling students. And this early intervention can sort of help uh, prevent academic decline and improve overall student outcomes. Then we have the personalized learning. So when it comes to personalized learning, predictive modeling allows educators or professors to understand each student's learning patterns and preferences. Now, with this insight, they can tailor instructional approaches and you know content which can suit individual needs and which can then maximize student engagement and achievements. Personalized learning can also foster a positive learning experience and help students reach their full potential. Then we have resource allocation. Now, in terms of resource allocation, educational institutions often have limited resources. when it such as teaching staff, tutoring programs, and learning materials. And predictive modeling sort of helps in allocating these resources more effectively by identifying students who would benefit the most from additional support. This ensures that resources are utilized efficiently to address specific needs of these students. Then we have retention strategies. Now, uh, as we all know, there have been high dropout rates and low student retentions, and these have become significant concerns in education. Now, predictive modeling can help identify factors contributing to student attrition attrition or attributes such as poor grades, attendance issues, or socioeconomic challenges. And institutions can then implement targeted retention strategies to keep students more engaged and committed to their academic journey. Then predictive modeling can also be used in the case of curriculum improvement. Now, by analyzing data on student performance, predictive modeling can reveal different sort of patterns or success or areas of weakness within the curriculum. And educators can use this information to refine and enhance teaching methods and course content and assessment practices, leading to better learning outcomes for students. Then we have college and career readiness. Predictive modeling can sort of help gauge students' preparedness, gauge in the sense of measure, students' preparedness for higher education or entering the job market, or by identifying areas where students may need additional support or skill development. And educators can then sort of focus on preparing them for a successful transition beyond their academic level. Then we have program evaluation. Now, educational institutions often sort of offer various programs and initiatives to support student successes. Predictive modeling can assess the effectiveness of these programs by tracking their impact on student performance over time. And institutions can then refine or expand successful initiatives while phasing out less effective ones. Then we have equity and inclusion. Predictive modeling can highlight different sort of variety or variables in student performance based on factors such as race, gender, or socioeconomic status. Now, and this insight can sort of prompt institutions to address inequities and implement targeted interventions to ensure that all students have equal opportunities for success. Now, let's talk about the flow of the project. First, we have imported all of the required libraries. Then I sort of went through all of the data set details. Then I looked for missing values. Then I did descriptive statistics. Then after performing descriptive statistics, I visualized all of the data. Then I selected the required features. Then I used all of the algorithms that are a part of supervised learning. Then a predictive modeling was done. And using the R2 and RSME score, final evaluation was done to find out which algorithm works best. So let's talk about the libraries that have been used in this project. There are plenty of libraries, so I'll just give everyone a brief overview of what each library is and does. So Pandas is like a popular Python library, and what it does is that it simplifies data manipulation and analysis. It provides intuitive data structures such as series, data frames, which sort of allows to effortlessly handle tabular and time series data. And with its powerful functions for filtering, grouping, merging, and transforming data, Pandas enables users to easily explore and gain insights from these data sets. And additionally, Pandas excels at dealing with missing data and supports time-based indexing, making it valuable for tasks ranging from data cleaning and pre-processing to advanced data analysis. Then we have NumPy. Now, this is like a fundamental Python library, just like Pandas, and it is used for numerical computing and data manipulation as well. It provides multi-dimensional array objects, unlike pandas, and that sort of allows for efficient storage and manipulation of large data sets. NumPy's array operations are significantly faster than traditional Python lists, which makes it like a more ideal choice for complex mathematical computations and scientific simulations. And it also offers like a wide range of mathematical functions, broadcasting capabilities, and integration with other libraries, making it a foundation for various data science and machine learning tasks. Then we have matplotlib. Now, this is like a very commonly used Python library or module, and it has been used on a large scale. It is used for data visualization, and it provides like a simple interface for creating various types of plots, charts, and graphs, making it easier to visualize data and present insights effectively. And with its with its flexible and customizable plotting functions, users can create line plots, scatter plots, bar charts, histograms, and a lot more, allowing them to sort of explore data distribution and patterns and trends. So Matplotlib also offers extensive options for labels, titles, legends, and color schemes, enabling user to enhance the visual representation of the data. And as a result, Matplotlib has become like this indispensable tool for data scientists or analysts and researchers seeking to communicate complex data visually and to make effective data-driven decisions. Then we have Seaborn. This is another Python library which has been built upon Matplotlib, and it is also used for data visualization, like I said. And it provides like this high-level interface for creating attractive and informative statistical graphics with minimal code. Typically, Seaborn is used to create heat maps and provide different color schemes along with it. Seaborn's functions and APIs are sort of designed to handle complex data sets, just like Matplotlib. It offers the same, visual graphs as well. This library sort of excels in presenting aesthetically pleasing visualizations, and it offers like a more different set of color palettes and themes, which makes it, which makes the graphs look more professional. Then we have sklearn.tree processing. Now this library is part of the scikit-learn library, and like I have mentioned a lot of like scikit-learn modules over here. Now scikit-learn is just used for machine learning, so we'll just dive deeper into each particular module. Just like I said, sklearn pre-processing is a module in the scikit-learn library, and it provides like a comprehensive set of tools for data pre-processing and feature engineering in machine learning workflows. It offers various sort of functions to transform raw data into a suitable format for training machine learning models and handling common pre-processing tasks such as scaling, normalization, or encoding categorical values and handling missing values. And this module sort of also includes functionalities for generating different sort of polynomial features and customizing feature transformations to improve model performance. Then we have sklearn model selection. Now this model is also a part of scikit-learn library, and it also offers various functions for efficiently splitting data sets into training and testing sets, and for cross-validation techniques, and for assessing model performance from hyperparameter tuning through grid search and randomized search. The module enables users to fine-tune models, optimize their generalization abilities, and avoid overfitting by systematically evaluating their performance under different conditions. Then we have sklearn linear model. Now this model encompasses a collection of linear regression and classification algorithms for specifically predictive modeling. And these algorithms are based on linear relationships between input features and the target variable, making them suitable for tasks where the target variable can be modeled as as a linear combination of the input features. And the model sort of also includes, I think, popular methods such as ordinary least square, which is usually used for linear regression, logistic regression, uh, and for binary classification. Then we have the sklearn metrics. Now, sklearn metrics is a module, again, in the scikit-learn library, and it provides like a comprehensive collection of evaluation metrics and scoring functions for assessing the performance of the machine learning models. In our case, the predictive model, and it includes a wide range of metrics for classification, regression, and clustering tasks. It also allows you to give F1 scores, mean squared errors, and more. It also includes giving the R2 score and the RSME score as well. Then we have the sklearn tree. Now, the sklearn tree is a model in the scikit-learn library that provides uh, like an implementation of decision tree based algorithms for both classification and regression tasks in machine learning. And decision trees are a popular non-parametric model that wouldn't be the right word. Recursively splits the data into subsets based on feature values, creating a tree-like structure where each leaf or label represents a prediction. Then we have the sklearn ensemble. Now, this module was sort of used to encompass all of the collections, all of the, create all of, sorry, my bad. It was used to sort of encompass all of the supervised learning algorithms and to, enhance the predictive performance in machine learning tasks. And it sort of ensembles all of these popular techniques such as random forest, gradient boosting, uh, ADA boost, voting classifier, linear regression, logistic regression, every algorithm, so that it sort of gives us an accurate score, uh, an accurate R2 score and the RSME score. Now I'm talking in terms of our project. Then we have used the lazy predict.supervised. This is a module in the lazy predict library, and it sort of offers this convenient and efficient way to build and evaluate multiple supervised machine learning models with minimal code and with, like, let's say, like a few lines of code, which we'll see in the demo as well. Users can sort of quickly train and test a wide range of classifiers and regressors on their data sets, which sort of saves time on manually configuring each fitting model. Then we have the iter tools. Now, iter tools is another Python module, a module that provides like a powerful set of fast and memory efficient tools for creating and working with iterators and for allowing efficient looping and data manipulation tasks. Then we have the sklearn SVM. Now, this module in the scikit-learn library provides an implementation of support vector machines. It is a powerful and versatile machine learning algorithm which is used for both classification and regression. Then we have the sklearn neural network. Again, another scikit-learn library, and it provides this user-friendly implementation of artificial neural networks for supervised learning tasks, specifically for supervised learning tasks. And neural networks, to just give a brief overview, are like powerful machine learning models inspired by the human brain's neural structure. And this model sort of allows users to build different neural networks with hidden layers, defining various activation functions and tuning hyperparameters, like the number of neurons and learning rate. Then we have the tabulate. Tabulate is like another Python library that simplifies the creation of well-formulated tables from data structures, offering an easy and efficient way to present information in a visually appealing manner. We have used tabulate to give us like this brief overview in the form of a table of the R2 scores, the RSME scores, and which algorithm gave us the most accurate predictive model. Now, coming to the dataset details and exploration. So the dataset contained information on the marks secured by students in various subjects, specifically maths, the writing score and the reading score, and it was sourced from Kaggle. This dataset, you know, served as a valuable resource for exploring and understanding the factors that influence academic performance. And by analyzing the data sets, different sort of researchers and educators can gain insights into how factors like parental background and test preparation impact student scores, and examining the correlation between student marks and etc. These variables can sort of provide valuable information for devising strategies to improve educational outcomes. Moreover, it can also sort of shed light on the effectiveness of various interventions, such as providing additional support to students with specific parental background, or encompassing all of these factors, and then encouraging students for a more rigorous test preparation. And overall, these data sets present an opportunity to explore the complexities of academic achievement, making data-driven decisions to enhance student performance and academic success. The data set had a total of 1,000 rows and 8 columns, and it has different factors, such as it had gender, it had a race or ethnicity, it had a parental level of education, the lunch type, the test preparation on student performance. So there weren't any sort of missing values, and I will show you the demo where we found that there was like none missing values. Let's sort of understand the descriptive statistics. So when it came to the gender, it was divided into male and female. For the race and ethnicity, it was divided into group C, D, E, B, and A. When it came to parental level of education, some had a college degree, some had an associate's degree. Mainly, there were also parents with high school. Some had high school form of education. Some had a bachelor's degree, and some had a master's degree. When it came to lunch, students were provided either the standard lunch, which had to be paid for, or and then came the free or reduced quantity of lunch. For the test preparation course, there were students who did not take the test preparation, and there was students who completed the test preparation. So as we can see, as we can see, when we compare the math score with the gender, we can see that males comparatively scored more than females. When it comes to the math score compared with different race or ethnicities, we can see that group E, or race E, scored more than group D, group A, group C, and group B collectively. When it comes to like the parental level of education, and then when we compare the math score, since the priority here is to predict the math score, we can see that. I think I'll just have to show this while during the demo. For now, let's just compare the math score and the lunch. So students who were provided with the standard lunch turns out scored more than the students who were provided with free food or the reduced quantity of the standard lunch. And when we compare our math score with the test preparation course, we can see that the students who completed this test preparation course ended up scoring more than the students, slightly, ended up scoring more than the students who did not take the maths, who did not take the test preparation score. Feature selection, let's sort of assume we take three variables, and I'm explaining this for the sake of understanding how we build our predictive model. So let's say we want to see our chances of getting into a specific college. So we take three variables. We take the age, we take the entrance exam percentile for that particular college, and we take the level of education. And using all of these variables, we then sort of build uh, this predictive model to see if we can match up with the college cutoff. And if we consider all of these three variables, just like I've mentioned here, I'll just read it. If we consider all the three variables to calculate the significance level for each feature and remove the features that have the highest p-value, till we get the desired number of features, we can then sort of have a thorough understanding of our chances into getting into a particular college. I'll just explain what do you say, the significance level and the p-value in like simple terms. Now, imagine we have all heard of what do you say, magic crystal balls, right? That can help us predict the future in different sort of cartoons or sci-fi movies. Let's say we have to predict if it will rain tomorrow. But sometimes the crystal ball might make mistakes and say it will rain when it won't, or vice versa. What the significance level in predictive modeling is like, a rule we set for the crystal ball. We say if the crystal ball tells us there's a 5% chance of rain, we'll only believe it if it's very sure and correct at least 95 out of, let's say, 100 times, since we said 5%. So the significance level, sort of helps us decide how much we can trust the predictions. And if the crystal ball predicts rain with a 5% chance, but it's wrong too often, we might not trust it. And on the other hand, if it's right most of the time, we'll have more confidence in its predictions, and the significance level, uh, is then sort of becomes like this safety measure to make sure we only rely on predictions that are very likely to be correct. Now, coming to p-value, let's sort of imagine we have this special item or a box that can predict if we can win sort of any game or not. The p-value would be like the score that tells us how confident that box is. Okay, that box is about its prediction. And if our p-value turns out to be small, it means that the box is very sure about its prediction. It's like the box will say, "Yeah, I'm almost absolutely sure that you will win." But if the p-value is big, the box wouldn't be that sure, and it might say something like, "Not really sure. You probably won't win this." So, to put it in short, p-value sort of helps us understand how accurate the toy's predictions are. When the p-value is small, we can trust how the toy or the box's prediction can be more confident. But when the p-value is big, we might not be so sure about the prediction. So the p-value is just like this little helper that tells us if the toy's predictions are strong or not. Now, coming to algorithms that have been used, I wouldn't go into explaining all the algorithms mentioned here, but I'll just give a brief overview about what really supervised learning algorithms do. Now, imagine we have this. I think we've all had a professor or a teacher back in school or in college who sort of will be open to answer many of our questions without any sort of hesitation. So you can, let's say, you show this professor some examples, and we tell them the right answers. Then this professor would learn from those examples and remember how to answer all of those what do you say, similar questions in the future, so that next time, let's say another student shows up, the professor sort of has this extra wide range of knowledge to answer the questions that we ask and we give the answers to. So supervised learning is just like having that, what do you say? Yeah, that helpful professor. We give the algorithm a lot of examples, and we then tell it correct answers. And then that algorithm learns from those examples and remembers how to answer similar questions on its own. So when we show the computer new questions or the algorithm new questions, it can sort of give us the right answers without really asking anybody else again. It's like it's just like magic. The algorithm learns to be smart all by itself. I've mentioned a few algorithms over here. I'll just read it out. There's linear regression that has been used. There's logistic regression. Decision tree algorithm has been used. Random forest has been used. Support vector machines have been used. Knife Bayes has been used. Gradient boosting, XG boost, and light GPM have been used. ADA boost and Huber regression. Now these are just the few algorithms present here that have been used. The library consisted like a lot of algorithms. I just picked out a few ones to to test the predictive model. Now let's sort of try to first understand what predictive modeling is really is. We have come so far into the presentation. I did not really talk about what predictive modeling really is. So think about predictive modeling as this super, smart friend, the topper of your class or your batch, that can probably guess what might really come into the exam, or what kind of answers you should probably write in like exams. What they do is they use their hard-earned knowledge, or special knowledge, to make predictions about things like if you answer this way, you would get the most amount of marks. And they sort of do this uh, by looking at the way that they have studied in the past, and then they analyze their own patterns to make really good guesses, or slightly predictive guesses about what might appear next, or how they can probably help someone else to answer a possible question. So what predictive modeling does is that it sort of helps us in imagining what might just come next, just like I mentioned magic crystal balls, just like that. And now that we have sort of understood about predictive modeling in like very layman terms, let's try to understand ensemble learning, since we have to use like multiple supervised learning algorithms. Ensemble learning plays a part over here. Now imagine that you're with your friends, and you have this big puzzle to solve together. Each friend would have their own set of what do you say, problem solving or puzzle solving approach, right? And they can and each friend of yours would have like unique uh, ideas to solve the puzzle really well. Now instead of solving the puzzle all alone, you guys would work together as a team, right? And each friend would solve their own part, and then you would combine all the pieces to complete the entire puzzle. That's what ensemble learning is like in a nutshell. So in technical terms, ensemble learning would be like having all of these little friends, which are different machine learning models, and each model is sort of good at solving a specific part of the problem. We let all of these models work together and combine their answers to make a super smart prediction. And by using ensemble learning, we can solve all of those tricky problems more accurately and make really good decisions, just like you would do with your friends while you're solving big puzzle together. So let's try to understand it more. I'll just try to elaborate on all of the bullet points mentioned over here. Now, ensemble learning, like I've already said, is like a machine learning technique where multiple individual models, known as weak learners, are combined to create a stronger and more accurate ensemble model. And each weak learner might not really perform perfectly on its own, but when their predictions are sort of combined, they complement each other's strengths and weaknesses, leading to this improved overall performance. And ensemble learning methods can be used for various tasks such as classification, regression, anomaly detection, and popular approaches, including bagging. One example of bagging could be random forest. Then we have boosting, where gradient boosting comes into the picture, and stacking. Ensemble learning sort of harnesses this power of collaboration with multiple machine learning models to make this uh, to make a, a most reliable predictor, and it is widely used to sort of enhance the accuracy and the robustness of machine learning models across diverse domains and data sets. In our case, student performance. Now, for the final evaluation, used in this predictive model, I have used the R2 score and the RSME score. Now, R2 score, I'll just explain it in layman terms again, so that everybody has like an idea of what we're talking about. Now, imagine you're, let's say, you're out there playing with your friends, and you sort of have this game about guessing how many uh, marbles are there in a big jar. We used to play with marbles, right, when we were kids, and each friend sort of takes turn and makes their own guess. The R2 metric is like this special score we used to see who made the best guess. When we calculate the R2 score, we look at how close each friend's guesses are to the actual number of marbles in the jar. And if a friend's guess is very close, they get a high R2 score. But if their guess is not very close, they get a less. They get like a really lower score. So the R2 score helps us to know how good our guesses are compared to the real answers. So the closer our guesses are to the actual number, the higher our R2 score will be. And it's like a little game that tells us how well we did in guessing, in our case, the marbles. In technical terms, R2 or R squared evaluation metric sort of measures how well a regression model fits the data by calculating the proportion of the variance in the dependent variable that can be sort of explained by the model's predictions. Coming to the RSME, now imagine we have this robot, okay, and it sort of counts how many marbles are in the jar. We'll just leave our friends out of the picture. We'll stick with the tiny robot. We just bring in our friends, and we just take turns and try to guess the number of marbles. Now, the root mean squared error would be like this magic scale that tells us how close our guesses are to the real answer. And this magic, scale would then, with the help of a robot, look at each what do you say? Yeah, our friends' guesses and the actual number of what did we take marbles here, and it then measures how far each guess is from the real answer and adds up all of those distances. It's just like the R2 score. It's very similar. Then it takes the average of those distances between the scores and gives us this particular number. Let's say if our guess was very close to the real number, we'll get a small score by the robot, which got the score from the magic scale. But if our guess was far away, we'll get a bigger number. So the RSME sort of helps us see how accurate our guesses are, and the closer our guesses are to the real number of marbles, the smaller the magic scales number will be. And it's like this special tool that tells us how well we did in guessing how many marbles are in the jar. And when it comes to the technical terms, RSME or root mean squared error is just another evaluation metric that measures the average difference between the actual values and the predicted values of a regression model. With the square root ensuring that the differences are sort of positive and the units of measurement match the original data. We'll just see, just a second. Yeah, we'll just see what do you say? The entire project is like on Jupyter Notebook. Just a minute, sir. Don't seem to. Yeah, okay. I hope it is visible. First, let's just take a look at the data set. Yeah, let's just take a quick view. So as we can see, we have the gender. In gender, it is split into female and male. Then we have the race and ethnicity. Again, it is just like I said, it was split into A, B, C, D, E. Then we have the parental. Yeah. Then we have the parental level of education. We have the bachelor's degree, some college degree, associate's degree, high school, master's degree. Then we have the lunch, just like I said, it is split into standard and free or reduced. For the test preparation course, again, same. It is sort of split into two, none or uncompleted. Then we have the math score. Just just sort of hanging. Anyway, we have the math score, the reading score, and the writing score. So in total, there are like 8 columns, and the total number of rows are 1,000. Yeah. So here's the code. What we have first done is that we have imported the necessary libraries in the beginning. I've imported and I've also talked about all of these libraries. I first displayed the head of the data to have like a brief idea about the initial number of data entries. So we can see we have like first 5 entries. Then I viewed the tail of the data. Yeah, it's the same. It gave us like it showed me the total amount of data present at the end. Then, as we can see, I described I found the information on the data. The gender, race, race or ethnicity, parental level of education, lunch, test preparation course are all objects. They do not have any numerical value. The math score, the reading score, and the writing score have numerical values, and they are of the integer data type. I used a df.shape to just find out the number of rows and the number of columns. Now coming to the detection of missing values, we can see that each column has like has the value 0, which just means that there are no missing values. Then we have done descriptive statistics to find a count of all of the let's say in the case of gender, to find out the number of females and the number of males. We can see that value as 518. For males, we can see it as 482. Then for race and ethnicity, we found the value for each group. For parental level of education, again, each value was taken. Each group's value was found out. Same for lunch, test preparation, math score, reading score, and writing score. and I have like described all of the all of the data, and I have found out the count, mean, standard, the minimum, and I have categorized it into 25%, 50%, and 75%, and maximum scores school. Coming to the correlation matrix, now this is necessary before we sort of get into data visualization. So just like I said in the presentation, we have compared the math score with the gender to find out that the male gender has apparently scored more than the female gender. When it comes to ethnicity, we can see that group E has scored more than all of the other ethnicities. Okay, we have the bachelor's degree. We have some who have gone to college. We have the master's, and we have the master's degree. So it turns out like the parents who have master's degree, their children ended up their children, or like they themselves ended up scoring more in maths than any other individuals present with like different level of education. When it comes to comparing the math score with the lunch, again, the students who had like the standard lunch, they scored more than the students who had free lunch or reduced quantity of lunch. This is the test preparation. So yeah, when we compare the test preparation course to the math score, we can see again those who have completed, they ended up scoring more than those who did not. This is the scatter plot for math score versus the reading score. This is the for the scatter plot for the math score versus the writing score. It's quite similar. Okay. Now, I first started off with building a predictive model without using the reading and writing score to see how accurately each algorithm works. And to find the best random state, I assigned the random. I just kept the random state as random. So it would just pick out which random state is gave this best score. What do you say? Predictive model, and we then have the best R2 score. I had some problem with the light GBM. I couldn't really get through, just removing all of the warnings, even though I used a library to filter out the warnings. There were okay 40 the total times the iteration was run was 42, and it turns out that the best random state over here was 37 and the best R2 score was 73. Then I used the decision tree regressor, and in here I defined the decision tree regressor, the logistic regressor, and the random regressor to find the R2 score and the RMSE score. So the decision tree regressor gave us an RMSE score of 62, while the R2 score was 0.74. When it came to logistic regressor, it gave us a value of 0.099, along with the RMSE score of 219, which is a lot. Another for random regressor, RMSE score was found out to be 35, and for R2 score, it was found out to be 0.85. I then decided to do predictive modeling with the reading and writing score. In this case, the logistic regression gave us 0.099. The random forest gave us an R2 score of 0.85, and the decision tree regressor gave us the R2 score of 0.744. Now, what I've done here is that I've taken all of the different algorithm sets from the library. I've taken linear regression, decision tree, random forest, gradient boosting. Some are different. I just listed a few of them in the presentation. We can see Lasso, Lars, Lasso CV, and SVR MLP are like the extra algorithms mentioned here. After running this segment of code, we can find that decision tree, gradient boosting, Lasso, Lars, CV, and SVR. These were some of the chosen algorithms, and they turned out to be the best algorithms, and they gave us an R2 score of 0.85. Over here, the algorithm set that has been used is linear regression, gradient boosting, Lasso CV, and MLP specifically, to find that the R2 score of all of these models collectively is 0.87. When we tabulate all of these data, this is like the ensemble prediction of like all the algorithms together. So once we sort of tabulate all of the supervised learning algorithms together, we can see that the Huber regressor algorithm, or the Huber regressor model, gave us the R squared or R2 score as 0.68, which is very similar to all of these algorithms or models. But the RMSE score of this particular model was 8.78. And when we compare it to all of the models, you can see that the RMSE score is very high. What we want is a model that can sort of give us the least RMSE score when compared to all of these models, and the R squared should be higher. But as we can see, it's 0.68 for pretty much all of the models over here, and all of these are supervised learning algorithms. Now we can finally conclude that the random state of 37 was determined as the most optimal for predictive modeling, and the R2 score was 0.73 without the reading and writing scores, and the R2 score was 0.87 with the reading and writing scores, along with an RMSE score of 5.5. And out of all the algorithms, when we made made like a huge ensemble model, the Huber regressor algorithm sort of performed the best in terms of R2 score. It gave us an R2 score of 0.68, and it gave us an RMSE value of 0.78. These are the references that I've used. So if you have any questions, please do ask. Should I come to the thank you slide, sir?
Yes, yes. Okay,
Yes,
so
I'm done.
I hope your presentation is done.
Yes, sir.
Okay, so this was one of your best presentation, I would say. Okay, you have done a really well done on researching everything, and also presenting it. But there are some things that you can improve. So can you show me your project, the IPYNB file?
Just a minute, sir. Sir, you've given me permission to share, right?
Yes, yes. It is okay even if you can't share it to some technical reason. Okay, yeah, it is
I
sharing.
think it is visible.
Yeah, yeah. Go to your Jupyter notebook.
Yeah.
Go to very top. Okay.
Where should I
See,
go, sir?
yeah, this is fine where you are. Okay. So when you started the presentation, right, it was a very good start, I would say. Very well explained what is predictive analysis, the scope of predictive analysis, right? That was really well done, I would say, well approached, as well as proper examples were taken. Somewhere it was technical, but it was like, it needed to be technical at that position, because you did like, explain it with really easy examples. Okay,
Yeah, yeah.
like insignificance value and things like that. You explain it really well. But when you are explaining your project, the thing is that, see, there are, let us say you are solving a puzzle, right? Let us say there is a puzzle, like, a jigsaw puzzle, right? You put together multiple pieces to create a picture, right? So
Right.
let us say there are two ways I can, like, imagine that puzzle. One is that I know how the puzzle looks like. It is a car, right? So that what I will be imagining is that I want to put together all the pieces so that a car is formed. Second is
Right.
that I will look at the puzzle and then I will say this puzzle looks like a car. Okay, I don't know what it
Right.
will look like, but I'm just solving using the puzzle, right? So there are two
Right.
different methods. Predictive analysis should be like, the first, where you know what you are trying to look at. Okay, like you should know what you are trying to do. But the thing is that your presentation was well put together, I would say. You, like, you talked about things like, let us say, what was that, libraries at the start. Okay, and then you also talked about other things. So I would say that your project was really focused towards the methodology. Okay, and so when you are like, really focusing on the methodology, the actual project demonstration becomes really important, because the project demonstration, what it will do is it will put together everything. Okay, all the pieces will fall
Okay.
into like, it will put together really well. So what you
Yeah.
can do is, so I think you can improve your overall project demonstration. So let us say you have DF head, right? So you just said that I have used DF head to look at the number of data, and the DF tail has told me how many data points I have, right? And then you said I have DF info. But the thing is that when you are performing a project, you need to not explain like what a particular function is doing, what DF head and DF tail is doing, why you are actually using DF head and DF tail. Okay, so let us say the, like, if I want to see, let us say I have a data set, I have loaded it in a pandas, right? So what I will be doing is, first I will look at the data set as a engineer to see what kind of data I am actually dealing with, right? So that is the point of using DF head and DF tail to check if, like, my data has consistency, as well as I can, like, humanly just look at the data set. Second is that you have DF info, but you only, I think, just went over the columns that you have already explained in the, let us say, PPT, right? But you have something more important, like D type, right? Data type. So that should have been covered in here. Second is that actually you don't even need to, like, go for the DF is null sum, right? You are just getting if there are any null values, right? But actually in DF info, you know that there are non-null values of 1000 and your overall shape has 1000 rows, right? So that is not needed, the is null for sum, right? So you see, like you have included a line of code, but it is actually not needed.
Okay.
Okay. So now you see the difference. So that was
So
my
basically,
point
I just
when you
have
were
to include
explaining.
like the
Yeah.
necessary things.
Not just necessary. Think of, like, your project, like my project, what I'm doing. Do I actually need to do this thing? Am I able to, like, reach my goal in, like, shortest route, or let us say longest route? So think about that. Overall, your, like, the overall presentation can be improved, right, with this, because in the project demonstration, I think you just explained the functions, and also the model part where you had like, done a lot of model. But the thing is that, can you tell me the specification of your laptop or computer?
i5, sir. 4th generation, 16 GB RAM.
Okay.
And
So
like
do
I
you
have a
think
GPU.
this can be done on a laptop without GPU and 8 GB RAM?
Without, what did you say, sir?
Without GPU and only 8 GB RAM.
Sir, it cannot be done, sir. Which is why I
Why?
did not really use my laptop. I did it on my computer.
Okay, because light, I think GDM requires some computational
Yeah,
value, right?
Yeah. Yeah, it does require GPU.
Yeah, so that should be also included in the presentation, I think, because let us say when you are actually implementing this on a client, right? So we also need this kind of information because you are the engineer and you need to provide this kind of information to, let us say, management team, to let them know that I need this kind of features. Okay, because
Yeah.
there is also one more thing, like we would like to save the cost, right? Cost saving is also important.
Right.
Second is that in, like, you know, in SNS document you have a let us say section where you talk about the requirement, like, you know, hardware requirement, so that can be included, I think. Other is that your presentation was good, okay, the conclusion was also good, but I think the conclusion, like, you know, was missing something, because you talked about we are doing predictive analysis on, let us say, children on math score, right? So I think overall that like, you know, how you explained it can be improved. Let us say you have gender, race, ethnicity, right? So why we actually have these columns and what they, like, you know, signify, and how they can be used for the predictive analysis, and how they, like, you know, overall on our research, what is the impact of this kind of thing. Let us say someone who has a lunch and someone who didn't had a lunch, right? So their performance will be different, because if you are empty stomach, like, you know, trying to study something, you might get distracted because you are hungry.
Right.
Second is that if you're like, we know that if someone's parental level of education is more, let us say if your parents have done MSc or BSc, let us say they are educated, they might, like, you know, push you to study more, right? And someone who is not, they will say that I don't really understand, then they might send you to a coaching class, right? So these kind of things are important, and I think, like, you know, when it comes to like, you know, explaining something to a client, you cannot be, like, you know, you have to speak of these things also, right?
Right.
So this is also important, so I think you can do that. Only thing I would say is just try to simplify it, okay? Other thing is that you are going really well, okay, just go on like this presentation is something like I can just score you 8 and 9, okay, and I will try to do that. I will, of course, like, you know, show your presentation to other team members also, because this is a good presentation and well researched, but I think there are, like, you know, small points that can be improved, so work on them.
Sure, sir.
Other than that, I think this was a really well presented. Okay.
Thank you, sir.
Yeah.
Yeah.
Thank you, Prithvi. Yeah. So Kalyani. Hello, Kalyani. Hello, Kalyani. Please turn your cam on and let me know the name of your task. No. I think there is some network issue on your side. I will move on to next intern. I will come back to you. Okay. Mahitha.
Yes, sir.
Yeah, please turn your camera on. Let me know the name of your task.
Can you see the screen?
Yeah.
So, hi everyone, my name is Mahitha. I'm Python developer intern. This is my second task. So, the title would be Overview of Project Synopsis. And I was required to develop a stock screener using Python. So, I've just implemented the mockup, like they asked me to design the interface, and I've implemented one example filter. So in this presentation, we will discuss the introduction, project synopsis, and the sources of stock market data. So like the different sources from which we could exactly get the data, which is publicly available, and some set of like filtering parameters like price to earning ratio or revenue growth, dividend yield, etc. And the basic working of the stock screener, and then I'll show the design of the user interface, how it would look like after developing. And as an example, I have shown like I've done the implementation of one filter, how the price to earning ratio would work, and then conclusion and my references. Yeah, so basically there are like why exactly stock screener is required is because there are so many stocks, like there are 60,000 plus stocks. So in those many stocks, we could like an investor, if you want to invest in one particular stock, right? So it's really hard for that investor to actually, like list out which, by investing in which stock they would get a successful investment, it would be successful or they'll get profit. So it's really hard for them to like go through every stock and then analyze its historic data and how the future performance would be. Like analyzing that is really, really a tedious task. So for that, a stock screener, this is basically a tool which will allow the investors to filter stocks based on the specific criteria what the investor is actually looking at. So based on their specific criteria, you could actually screen through these stocks, and a manageable list is provided. So from those stocks, you can narrow down, like the narrowed list is provided. From them, you can choose the stock by analyzing their history and predicting their future, how it would be their performance. So, but you can also see that screening criteria, it alone cannot guarantee successful investment. It's because there are certain shortcomings in them, like the screening criteria. It's basically when you screen a criteria. So the thing is, whenever you want to analyze the data, so you are using fundamental parameters, right? So whatever you're analyzing, the data is publicly available. So if the data which is publicly available, there is other data which is not actually available. So you cannot exactly guarantee that the result which you get from the stock screener will be successful, like if you invest in that. So that's not guaranteed. And also the stock screener are very like essential, or they work very prominent for a short term, but for a successful investment, the long term is actually the goal, right? So the short term is does not play a major role here. So the stock screener will only help for the short term period, but when you look for long term, so this is not exactly what you're looking for. Stock screener alone cannot help you in that because the market conditions are so dynamic. So from this, we can actually tell is only screening criteria cannot guarantee a successful investment. There are other factors which also you have to consider if you want to actually gain a huge profit in particular stocks. So in this project, it is basically done a user-friendly Python-based application. It will enable the investors and traders to filter stocks based on different criteria like price to earnings ratio, dividend yield, revenue growth, or any other filters. And this application makes use of the real-time financial data APIs. Like there are a few financial data APIs like Alpha Vantage, Yahoo Finance, Google Finance, like different APIs which you can make use to get the real-time data which is available. And also it delivers a user-friendly interface for effective access to set their preferences, which sector or category they are actually looking for, and to set their preferences and get the data which they're actually looking for, the specified data. So these are few of the sources for stock market data. So there are basically several sources to collect the stock market data. One of them would be through financial data API. These are the major ones: Alpha, Vantage, Yahoo Finance API, and there are other potential financial data APIs too. So by using these APIs, we can collect the data that is required for stock screening. So while coming to Alpha Vantage, so this is basically a popular financial data API. This will give you data which is like daily data or weekly, monthly, or even a specified like small period in a day, like 10 to 15 minutes, like anything. And this Alpha Vantage also has also other features. Like it also gives the technical indicators, like it also offers wide range of technical indicators. This will uh, give like this will give the investors like other broader view through which if they want to invest or not invest, this that will help in that way. And when you request from this Alpha by using Alpha Vantage API, the response would be in the form of JSON or CSV formats. Then just they have to analyze the data for further usage. And there is one more finance API. So the thing is, in Alpha Vantage, whenever you want to access data, right, you need a API key. So you need API keys because that is API key is used for authentication, authorization. Like if you are an authorized user, like every user gets the API key, you have to use, you get it from the Alpha Vantage. There is a site. So from that, every user will get a key that is just for authorization purposes. But Yahoo Finance API doesn't need any authentication, like anyone can access without any signing to account or anything. So Yahoo Finance API also provides real-time and historical data. So user could access the most recent trading data to stay updated, and also it allows historic data for various financial applications. So these are a few APIs, and these are also other potential sources using which we can access the data. So there is Bloomberg Terminal, Quandl, Google Finance, and brokerage platforms. These are some other examples. Even Bloomberg Terminal is actually a widely used financial data platform that also offers this real-time historical financial data, same as the Alpha Vantage and Yahoo Finance API. And Google Finance, it doesn't. Google Finance, it provides the financial data from using these financial data providers. It does not provide its own, like by its own. It uses these data providers like NYSE and NASDAQ. Like by using this, Google Finance provides the data. So once you have access to the data, like you got the data from different stocks, like from different sectors or anything. Once you retrieved it, now you can filter them according to your criteria. So basically, user specifies what kind of criteria they want. According to them, the filters could be like the criteria they set. That could be the price to earning or dividend yield or market capitalization. So these choice of which criteria to be used, that will be according to the user requirements or their goals and their strategies. So, in that price, one of the like fundamental or like the important thing would be this price to earnings ratio. This is a fundamental financial metric. It is used to evaluate the valuation of a company's stock relative to earnings. This is the widely used and important valuation ratios in the stock market. After this, there is one more filter, that is dividend yield, and this is also this is also a financial ratio. It is also used to measure the annual dividend income that is generated by company's stock related to its current stock price. And there is one more called like market capitalization. It is also a key financial metric used to measure the total value of a publicly traded company. These are a few of the major filters. Other than this, there are many other filters too, like there is revenue growth, and many others. So this is the basic working of a stock screener. So the first thing would be the data collection. It collects the relevant financial data from wide range of stocks. You can even specify your sector through which you want to collect, or specify your organization. Like if you want to exactly collect from Apple or Microsoft, you can specify that, or anything like from where exactly you want to get relevant financial data. And then you have to select your criteria. That would be, for example, like price to earning ratio or revenue growth, like what exactly you want to. That depends on the user requirement. So selecting criteria, user defines the criteria or parameters for filtering stocks. Then the filtering process, your stock screener uses selected criteria to filter stocks that meet specified requirements. So all stocks are filtered according to the specified criteria. Like one or more filters also can be used while filtering, and the results are displayed. All the specified results which will fall under the specified criteria will be displayed. So this is an example, like a mock-up of the user interface, how it might look like after the complete development. So here the user can choose like whatever organization, like the ticker symbol can from here, either Apple, Microsoft, Google, or any other organization, and the data source from which they want. This would be the filter, like price to earning ratio. Here in data source, you can choose by using its API. So here you would list like if you want to use Alpha Vantage API or Yahoo Finance or the other ones like Google Finance or any other. And then the filter you want to apply, as of now it's one filter. So, and then after you choose everything, then you will get a interactive chart for that particular organization. Like for example, Apple's chart will be displayed. So as of now, these are the features and functionalities, like selection of the ticker symbols is nothing but the Apple, Google, or any other organization. And then the filtering criteria input would be like PY ratio or revenue growth, something like that. And data source selection would be by using the API you want to collect the financial data from different organizations, like of different stocks all over. And then the range service, like for example, you take a P ratio, you can also select the range from where to where you want to filter, like 20 to 50 or 0 to 20. You can choose that a slider. And in further improvements, you can add the sector and industry, like education sector, health sector. These also can be added in the app. And additional filtering parameters, like other if there are any new filtering parameters or any others which are not there right now, like they can be added. So I have done the implementation, like to show the working of only PV filter. So here it would be, yeah. So basically, this is a function to get P ratio. So here, whenever the user, this is the API key which you will get from the site. This is different for different users. This is basically used for authorization. And I've used these the list of these stock symbols, like as of now, it's Apple, Microsoft, Google, Amazon, and Tesla. Then the P filter ratio, I've given the ratio of 0 to 50. After like defining everything, then the after defining like the setting the criteria, then for every organization, like every symbol in this thing, it is you get the P ratio for everyone, like Apple, Microsoft. For that, this is the function to get the P ratio. So first thing is basically when you want to like access something through API, you need a request. So here the request would be base URL. The base URL is first one is Alpha Vantage query. This is to send any query as a request, and this along with other parameters like the function. This overview is a function which is used to get the fundamental data. So along with this base URL, which is for any query you're sending, you use this URL, and this URL is appended with overview and the symbol and API key. Symbol would be from the list and API key is the user one. And so this is the final URL, which is actually going from this. So once you send the request using this, request is sent by using this URL, you can see like this is the result. These are all the JSON objects, and then you can analyze this data and you can get whatever you want. So for dividend yield, you can access this one to get dividend yield, and also for price to earning ratio is also given. So you can access whatever, here is the PE ratio. So whatever data you want to access, you can like go through this response, like, yeah, so this is the response which is given, then you have to analyze this response and get the required data. So in this example, I want to filter P ratio, so I'm only accessing P ratio from this. So here P ratio, and you will access this one. And here this is for Apple. You can see in URL here. So this symbol would be changed like for different organizations. So right now the symbol is Apple. So Apple's P ratio would be here in this object. It's 31.67. So once I have given Apple 31.67. So similarly for others also the P ratio we get. And after that, for every P, like you get P ratio for everyone, then you filter all the P ratios based on your minimum and maximum P ratio which you have defined. Like mine is like 0 to 50. You can change it to 20, or you can change the number according to your requirement. So all the symbols which are in between 0 to 50 are displayed here. So the others are greater than 50, like Amazon and Tesla. It's greater than 50. So this is the basic working of P ratio filter. And similarly, if you want any other filter, so it's nothing but the only thing you have to change is you have to just get different data from here. Like if you want to access dividend yield, then just write dividend yield instead of P ratio. So similarly, just change whatever you want to get, and by using them, you can actually filter out like any responses you want. So those filters would be specified here in the filter, so that will be changed accordingly according to the user selection. So this is the basic working. First, so I only use request module here, only for sending requests from Google or like for sending requests, and then the symbols I've used here is Apple, Microsoft, and you can use other organizations too. And you can set the filter range, like since this is P ratio, it has a filter range, like even other parameters might also have. And after that, after you fetch the P ratio, you can after you fetch the P ratio in that particular filter range, but like while you're fetching, you can set the API parameters and API request and data handling. As you have seen, while sending an API request, the base URL should also contain your authorization key and also what data you want. For example, in price to earning ratio comes under fundamental data. So there is technical also and others. So overview is the name for fundamental data. So if I want since I want fundamental data only from that stock, I'm using this function. It changes the function changes according to the requirement. After you define everything, then you send the request. Then the data handling, the response. So you analyze the response and extract the required data. After that, the filtering and storing of stocks and display the filtered stocks. So from this stock stream application, I have understood that it is a really powerful tool that enables investors to efficiently filter and screen stocks based on specific criteria, and also the like major important thing is it saves a lot of time, and you can use multiple filters and analyze like lots of stocks, and you can narrow down to very small list, which you can analyze their historical data, and also you can forecast about how the future would be. So this saves a lot of time and effort in manual research. So it also simplifies the process of finding stocks that meet predefined criteria. So in this case, I have predefined, but in general, you can by using this interface, you can select the criteria which you are interested in. So, and by combining the power of a stock screener and with informed decision-making, investors can enhance their ability to identify suitable stocks. Yeah, this, as I said, like in the starting, stock screener alone cannot actually help you in a successful investment. If you are looking for a long-term or a really good investment because it solely relies on only the publicly available data. There is hidden data which you cannot access directly. So for that you need to properly research about entire company and their previous stocks growth and all. So through this you can identify suitable stocks. So these are my references. Yeah, you end the session.
Then are you done?
Yes, sir.
Okay. Can you see your presentation was good? Okay, the way you have created the presentation, also the content was fine. But you need to work on your project demonstration skill. I think it was not really well explained. And also when you are explaining, like you have a code, then it is good idea to run that code. Okay, so can you run the
Yeah.
code again and show me like some other
Yeah,
things?
I forgot. I forgot it.
So right now, which symbols are you using for which companies?
I've used only 5: Apple, Microsoft, Google, Amazon, and Tesla.
Okay, so you are getting values for Apple, Microsoft, and Google, right?
Yeah, others are about, like, I've set a range here, like 0 to 50.
Okay,
So it's only coming under 50.
yeah, okay, okay, sure. Okay. Try
Yeah.
changing it. So remove the Google and then run the code. Yep.
That happens in between, so I just reinstall and do.
Yeah, sure. No issues.
Yeah, yeah.
So try changing from 0 to 50. Let us say 75. You can say exclamation keep install, then it will install. You don't have to run it again and again.
Yeah, so the thing is, if it is more than 50 or many things, like it's not coming. If it's less than 50, it is playing the P ratio. For higher values, it is not displaying.
Why is that? Can you tell me why that is the issue?
I don't know. I've tried for 20, 30, it's all working, but if when it goes higher than 50, it's not working. This happened before also, like then I asked, they were like understanding it enough. So I didn't really ask about it.
Yeah, now it is correct.
Maybe the
Okay,
Palak
so
one.
now you are also getting Tesla value, right?
Yeah.
Okay, good. Yeah. Okay, thank you for your presentation. I think it is already 9:08. The code is running, so no
Yeah.
issue with that one. But to work on explaining the project itself, that can be, I think, improved. What you can do is, let us say you are doing a presentation, right? So try to include that also. Let us say if you have a code, try to have a flow chart to explain the logic, right? That will be much more better. As well as in the Google Colab, what you can do is you can say exclamation pip install, then it will install
Yeah.
it in your environment itself. Right now, what it is doing is you have to install it every
Yeah.
time you are using the code, right? That is why you are getting there.
Yeah.
So that can be done. Other than that, okay, the code is working, so no issue with that. You can stop the screen share now. We will be done with today. So Kalyani, we will have your presentation tomorrow at 7 p.m. Okay, you can join at 7. I will call out your name. You can give your presentation. You don't have to wait in queue. Okay. So I think we can conclude session here for the day. It is already 9:10. So thank you for joining. We'll continue tomorrow.
Thank you, sir.